Now that we've reviewed how to solve different types of equations, we're going to be looking at how to solve word problems that involve those same types of equations. Students often find word problems somewhat challenging. While there's no exact way to do every word problem, there are some steps or strategies that I can give you that can help make these a little easier. Step 1. Read the problem carefully. Ask yourself, what are you solving for? Let that be your variable. Try to write anything else that's unknown in the problem in terms of the variable you already have. If you've already decided something's going to be x, try writing the other one as half of x or x minus 3 instead of introducing a new variable. Once you've come up with an equation, solve your equation and see if it answers the problem's question. Then check to see if your answer makes sense within the context. If you get x equals -4 and you're supposed to be solving for distance, you know that -4 can't work for distance. So let's take a look at problem number 1. After a 30% price reduction, you purchase a new computer for $840. What was the computer's price before the reduction? So I'm going to let x be the price before the reduction. Here's my price. Then I'm going to take away 30%, right, after a price reduction of 30%, which means I'm taking away 30% of the original price. Then it tells me that after you take away 30% of the original price, you pay $840. So now I can solve this equation. 1x minus 0.3x equals 0.7x. And if I divide this problem by 0.7 on both sides, I get x equals 1200. So what I want to write for my final answer is kind of more of like a sentence. And in my sentence, I want to state what I was solving for, and I want to make sure I use units. So I would write the original price was $1,200. Here's another problem that we're going to look at, and this one involves using a formula. So some of the formulas we're going to look at are area and perimeter, of rectangles. We might also need to know the formula for the area of a triangle. Let's fix this. Here we go. Okay, so some things that we might need to know are the area and perimeter of a rectangle, area for a triangle, area and perimeter for circles. Remember that circumference is another way of saying the perimeter, the distance all the way around a circle. The Pythagorean theorem, which is a formula which we use for right triangles. And then an average formula. So let's take a look at problem number 2. The length of an American football field is 200 feet more than the width. If the perimeter is 1,040 feet, what are the dimensions? So for these problems, it can be really helpful to draw a picture. We know it's a rectangle, and we're told that the length is 200 feet more than the width. So if I call the width W, then the length should be 200 more than W. It can be really helpful to label your picture all the way around, because now we know that the perimeter is going to be 2 times the width, right, so 2 of these, plus 2 times the length, 2 of these. But we're told in this problem that the perimeter is equal to 1,040. Distributing and simplifying and combining like terms gets me 1,040 equals 4W plus 400. Then I get 640 equals 4W. And finally, W equals 160. So here's a critical part. Remember that in this problem I was asked to find the dimensions, not just to find the width. So if the width is equal to 160, then the length is going to be equal to 200 more than 160, or 360. So again, I want to answer the final question in somewhat of a sentence. The dimensions are going to be equal to 160 feet by 360 feet. Notice that I write out the units as well. Let's take a look at another problem that involves rectangles. A rectangular garden measures 16 feet by 12 feet. So again, let's draw this. A path of uniform width is to be added to surround the entire garden. So I'm going to make a little path. And it tells me that the path has uniform width, but I don't know how wide it is. So that's going to be my X, okay? So on my picture, this is X, and this is X, and this is X, and this is X. So now let's look and see how long my path is. My path is going to be 16, that's this part of the garden, plus you notice that I have an X on each side. So the width of my path is now 16 plus 2X. Let's look at this part. This part was 12, but again, notice that I lengthened it by X on each side. So this is now 12 plus 2X. It says that the landscape artist doing the work wants the garden and the path to have an area of 320 square feet. So the area which is going to be 16 plus 2X times 12 plus 2X should be equal to 320 square feet. So I'm going to FOIL out the right-hand side. And then I'm going to solve this quadratic equation. Oops. The easiest way to solve this equation is to factor out 4. And then factor the remaining polynomial. In this case, I would get x is equal to 2 or negative 16. But remember, it has to work in the context of the problem. So the path cannot be 16. Therefore, the path must be 2 feet wide. Let's take a look at a problem that involves a triangle. A radio tower is supported by 2 wires. There's my tower. There's a wire on this side. Notice that it forms a 90-degree angle with the ground. It says the wire is 130 yards long, and it attaches to the ground 50 feet from the base. How tall is the tower? So that's going to be my x. And because this is a right triangle, we're going to use the Pythagorean theorem. X squared plus 50 squared equals 130 squared. In other words, the square of the legs added together equals the square of the hypotenuse. You get x squared is equal to 14,400, and therefore x is equal to 120. So again, writing this as a sentence, the tower is 120 feet tall. Right. In the last problem, we're going to take a look at how to use an average equation. A group of people share equally in a $5 million lottery prize. Before the money is divided, 3 more winning ticket holders are declared. As a result, each person's share is reduced by $375,000. How many people were in the original group of winners? So what I'm going to do is I'm going to call X the number of people in the original group. So think about having a $5 million prize, and there are 10 people in the group. How much would each person get? To figure that out, we would take the $5 million and divide it by 10 people. So if there are X people in our group, we'll take the $5 million and divide it by X people. This is your original share. But we know that after more people come forward, this number decreases by 375,000. And this is going to be equal to your new share of the prize. So what is your new share of the prize going to be? It's going to be $5 million. But this time, instead of dividing by X, the number of people in the original group, you're going to divide by X plus 3 because 3 more people added to the group. In this problem, the easiest way to solve is to cancel out the fractions by multiplying by the least common multiple. X times X plus 3. So let's see what cancels. These cancel, and we get 5 million times X plus 3 equals 375, oops, that's a minus, 1,000 times X squared plus 3X equals, these cancel, 5 million X. So this looks like a complicated equation, but we just worked through it very slowly. When we simplify this equation, we end up with X squared plus 3X minus 40 equals 0. This can be factored into X plus 8, X minus 5, and we get X equals negative 8 and X equals 5. Now again, we go back to the context of the problem. How many people were in the group of winners? Well, you can't have negative 8 people in your group of winners. So therefore, there must be 5 people in the original group of winners.